All right, so today we're going to talk about the 3D Arrays project called Pesky Tourist. And so to get into 3D arrays, what we're going to do is we're going to review 1D arrays and 2D arrays, and that, looking at those patterns, we should be able to answer the following questions, which is, how do we create a 3D array that holds 9 frames of 495 by 557 integers, let's say. Okay, so 9 frames of that. You might think of it as a picture in processing. The second question is, how do we get the length of each dimension using the dot length parameter? With the 3D array, as you might imagine, there's going to be 3 dimensions. And finally, how do we go through and set all the values in this array to an initial value, let's say -1? Or, for example, go through all the values and print them out. Both things would be very similar. So let's just review. This is how we would do it in 1D array world, right? We could create an array of length 5. We can get the length by saying the array name dot length, and we can cycle through the array with a for loop. Similarly, with the 2D array, we can specify 2 dimensions, which could be represented as either of those grids below. And we can get the first number by saying a dot length, and we can get the second number, or the second length, by saying a of 0 dot length. All right, so the first number, a dot length, would be 3 in this case. The second number would be 5. And we can use a nested for loop, as pictured below, to go through the whole 2-dimensional array and put a grid of -1 in there, for example. And so looking at both of these, you should be able to figure out how we might create a 3D array, for example. How we might figure out the length of the 3D array, right? What would a dot length be, a 0 dot length? How would you get that third dimension, right? And how would we cycle through this? If the 1D array is a for loop and the 2D array is a nested for loop, how would you get through all 3 dimensions of the 3D array? So that's the first to do. Pause the video and try to write that out, and then I'll meet you at the next slide. So we've been thinking of a 2D array as a grid of values. In processing, for example, we could call a 2D array a black and white picture, right? Something where you have a bunch of integer values from 0 to 255, and that would represent this picture, right? And we can now think of a 3D array as a bunch of these images. So this is a flip book I got from Google Images, and you can see that if we have many pictures, we have many 2D arrays, we just have another dimension. So if each one of these pictures is 138 by 108, what is a 3D array that will store these black and white images? So how many black and white images do you have to store, and how would you create that 3D array? And that brings us to the final kind of assignment of our primitive array world. And it's called the pesky tourist. I'm not innovative enough to come up with this assignment. So it was taken from something called Nifty Assignments. And I really enjoy this assignment. And it's pretty straightforward. You try to take a picture of the statue. So let's say you go to a college and you try to take a picture of the statue, and you're foiled 9 times by the pesky tourist. And so the pesky tourist just foiled you 9 times. And obviously you assume that one of the pictures is okay, but then you get home and you're like, I can't believe I didn't notice this dude in front of the picture all these times. And you obviously want an unobstructed view of this beautiful statue in the middle of campus. So you're thinking, well, all is lost, but is it actually lost? So you can actually think about this. If you looked at this, you probably have figured out that there's enough information to get rid of the pesky tourist. Okay? And you could probably do it with scissors. You don't have to think too hard about it. But we're not going to do it with scissors. What we're going to do is we're going to create a median filter. And for each pixel, we're going to figure out which of these pixels is the median pixel and grab that one. If you remember what the median is from math class, it's when we sort a group of values and we take the middle one. So what a median filter does is it eliminates the high values and the low values, leaving just the middle values of the pixels. And that's what we want. We're going to assume that this tourist is going to change particular pixels. And so we want to get the ones that are in the middle that are not high and not too low. Because this one, every time the person obstructs it, it's going to be an extreme value, is what we're assuming. So let's think about how we might do this in processing, okay? So I have these 9 pictures, okay? And the first thing we need to do is we're going to read them into a 3-dimensional array, as you might have guessed. And then what we're going to do is we're going to cycle through for each pixel. So this is pixel 0, 0, and we're going to grab the pixel value at that location. Now for this particular assignment, we're just going to grab the red channel. And the reason for that is because it just makes it easier. But as extra credit, you can grab all 3 channels and do it in color. We're just going to do it in black and white, and that's all I'm requiring for this particular project. And so if I grab the red channel, and you can grab any of the color channels. We're just going to grab one color channel and we're going to do this in black and white. But feel free to, again, redo this in color for extra credit. And if I grab the red channel, I get the following values at 0, 0. Okay? And then I can use processing sort algorithm, a sort function. I'm sorry. I'm going to say sort function. And you will learn how to sort pretty soon. But right now, it's not super important. So we're going to cover it later in the semester. So we're going to sort this pixel array, and we're going to get these pixels in order. Okay? So we have a pixel array of 9, right? Index valued 0 to 8. We sort it, and we get, using this sort function, and its output, a pixel array will just be sorted after that point in time. And so then we grab the middle index value and figure out which index that is in a in this particular case, right, where our index values are 0 to 8. And we grab that 240, which happens to be at the index we need to get. And then we set 0, 0 to 240. We're throwing out the extremes, right? We've thrown out 238 and we've thrown out 254, and we're sticking with the middle value, okay? And hopefully, when we reconstruct the image, so then we're going to write that out at pixel value 0, 0. And as you might imagine, we got to do it for 0, 1 and 0, 2 and 0, 3 and 0, 4, right? All the way to whatever the height and width of this image is, right? So we have to go through all of that. And once we get there, we should be able to get an image that's devoid of the pesky tourist. Okay? All right, let's talk about a few details here. And they're just processing details. These details are also covered in the processing comments of the program. So feel free to read those too, but I wanted to take a second to kind of explain what you will see in those processing comments, because it looks like a wall of text when you actually see it. So the details are specified in the to-dos and code. No need for void draw on this project. Everything can just be in void setup, okay? And if you want to put something in draw or have something happen when you hit a keyboard press or something like that, or try different things, like you could do an average of all the pixel values and write it out, and so you could have different image processing functionalities, feel free to do that. Just clue me in on if you do that, so I can give you extra credit accordingly. So if you look at the data folder of the project zip file, please unzip the zip file, by the way. Do not try to open the processing project in the zip file, or else you'll have issues, right? If you look at it, what you're going to see is a bunch of images numbered 0 to 8. And what's nice about that is that allows you to cycle through the images in a for loop, and you can just kind of use string manipulations to get the index value, take whatever index value or control variable you're using for that for loop, and load that picture. Okay, we will place the image on the screen so we can read out the pixel values. So remember, in processing, the way we read pixel values is we first put the image on the screen, and then once the image is on the screen, we can read the red, green, and blue channels. In this case, we're just going to be reading the red channel, or one of those channels, any channel you want. And we're going to read them into a three-dimensional array. When we if we specify an X index and Y index, just like we did in the last project, we can get the red value by casting it to an int, remember, and then using this red function and this get function to get the X and the Y value there. So that's how we get the red pixel value at a particular pixel index. That should be a review from last time. But we can talk about it if you need help with that. And finally, you can sort the array by just saying sort array, whatever your array name is. And at that point, your array will actually be sorted. It does what we call sorting it in place. So what that means is it changes the actual array by moving its values around inside the array, and array is now sorted at that point. So it changes the original array, and since it changes the original array, we say it's sorted in place. Sometimes you might come across a function which is not sorted in place. That just means it creates a copy of the array and that copy is sorted. But this is nice. It'll sort it in place, so at this point, array is sorted. And then we just have to set the particular pixel value, like in the last slide, it was 0, 0, right, to whatever the median value is at that pixel. I think I'm missing a parenthesis on that statement, but you can probably figure that out. Okay. And so that's about it. I don't think there's anything else. Oh yeah, there is one thing. Extra credit, you can do it in color. All right, so try to get rid of the pesky tourist, and please talk to me if you have any issues. I'll see you in class.